Hi, I'm Rick.
Hi, I'm Oscar.
So, Oscar, we already looked at Cosmos DB, I think twice now. So,
Yeah, we had the SDK, we had
Yep.
entity framework connection to it, and we did
And
some
the
Azure
bindings,
functions,
yep.
bindings and triggers.
cool.
Really cool. Next up, what I wanted to talk about is the API for tables,
Yeah,
because we mentioned that before. So I just made some demos, and maybe interesting to talk about that. Because table storage on Azure Storage is a thing that is cheap, fast, scalable.
yes.
So it's really nice. I don't know if you ever read Troy Hunt's blog about it, that on a cappuccino budget, he created one of the biggest services you can imagine.
Yes, have I been pwned?
Yeah, so storage is really cool, but there's also a table storage API on Cosmos DB.
Yeah.
So thinking about like why would that be necessary? Well, first of all, you have the global presence, which you don't have in a storage container because that's a regional thing. So that's one. But the other one is actually more interesting to think about because table storage is really fast.
Yes.
But it's really fast within its limitations because every table starts with a partition key, which just physically is a different endpoint in the end. Like it will balance the load out, knowing which partition you have. And there's a row key, which is unique within the partition.
Yes.
So knowing those two, it's a really strong key value collection because you can just get it in an instant. So table storage is really fast for those things.
Yeah, and they call that a point query. So if you know which partition key you need and the row key, then it's blazingly fast.
But imagine like you have multiple partitions, and every partition has some generic row key, but you are looking for something else, some other field of that entity, and you have to query on that. It's not only going through a table scan, but it's going in parallel through full scans on all the partitions.
Yes.
So in that case, it is not that fast. And I think we all found out what if you're creating a model, when it's interesting and when it's definitely not the good solution, and something like SQL or Cosmos might be a better solution because you want to look at it from multiple points.
Yes.
And you can go for, I had a solution once for table storage where I optimized for reading in a different table.
Yeah.
But then you're writing yourself double. You have to do all kinds of tricks to
you have to
make
keep it in
interesting.
sync and that kind of stuff.
So going back, if you are interested, the first video of this range, this sequence, we did some Cosmos about what it is and how to create it. But for now, we actually want to see the two types of storages. So on Azure Storage, Table Storage, and the Table API. For that, we're going to go to Visual Studio and the portal. This is a Cosmos DB account created with the Table API. So you also see Azure Table API. It has one database in there. It's the Tables DB or the Table DB. And it has similar, again, persons container. Yeah?
Yeah, I was waiting for you to say collection.
Waiting for me to say collection, yes. This is a container, which is actually a table in this case, because it's only the Table API. Clicking on that, you have the entities, and actually the interface that we're also used to from the Data Explorer in Table Storage.
Yeah, and it even looks a lot like the Cloud Storage Explorer that you can download as a separate tool.
Yes, that one, yeah. But you also have them in the portal these days, which I think is very handy.
Yeah, that's awesome.
The only thing I'm missing there sometimes is the export. It's not there, which is in the normal Windows tool. So this is the Table API in Cosmos. But just for comparison, I created a storage account and also created a table called persons, which contains roughly the same data. I have some partitions in there. The keys I just generated some GUIDs in. I pushed a lot of data in there. I think there's a couple of million records here right now.
Nice.
So I'm also going to show you about the ingress, how fast it goes in and out. But let's go to Visual Studio. I did a really simple test. So I have a person clause because that's my entity.
Yeah.
Of course, because it's table storage, you inherit it from table entity. No weird tricks further here. Then I do a cloud storage account.parse on the connection string.
Yep, for getting a cloud storage account.
Yeah, then you have the account. From the account, you want the table client. And from the table client, you get a reference to a table, or collection, or container, or whatever it is. In this case, I have two configs, one called table, and the other one is called Cosmos. So this is actually storage connection. So I have a retrieve entity here. So getting, if you look at that thing, it's here. So it's doing a retrieve operation on partition and on row key.
Yeah.
So this is the really simple, efficient
This
version.
is the point query, right? Where you just say, get me that one.
Yes. I know that it exists, or that it probably exists, and then it's there.
Yeah.
So yeah, that's like dictionary based. Next in line, I have a query that, or a method that queries. And I actually query only on email address that's in there. And I pushed millions of records in there over multiple partitions, but there's one in there with this email address.
That should be horribly slow.
This is different, let's say that. Because it like on the multiple partitions, it needs to query and I have to wait until all of them finish and collect that.
Yeah.
Also, it's more Azure problem than my code's problem, but still, it's explainable why this wouldn't be too fast. So I'm doing some logging in there in console.write. So we should be able to see it says retrieving directly. Well, this is my first F5 spin up. So it's also not that fast, but did more than 5 seconds to get the other one. Which is still, if you think about what data it is, and it's not index data.
Then it's still impressive,
For full scans, it's pretty impressive.
Let's do it again.
Let's run it again. It felt a bit slow, but
all warmed up.
yeah, but I'm also killing the process again. But still, not too fast at this point.
Yeah.
It's a big collection. There's a lot of stuff in there. Then I have another one to show how to push some data there.
Yeah.
Pushing data there, for instance, I just create 10,000 fake persons. It's a bit horrible code at the moment to see because you need the batch operation. You can only do a couple of, you cannot do like 10,000 in one batch.
No.
So it's a bit of a weird loop, but what I'm actually doing is writing out every 500 how much time has passed since the last batch, which are actually 5 batches. So if I just uncomment this one and I let it run, you will see the speed of the ingress of table storage. And I'm also on some kind of Wi-Fi connection right now, so it's not too weird. The first one is it starts at the run, so well, this is like 7 seconds for 500. Wait for it. Again.
7.5 seconds.
So we've got 1,000 records in. Not that fast, right?
Oh, well, it's going down a bit now.
Yeah, but it's also a bit dependent on our connection, which is pretty good,
course.
but mostly latency. So you see what it's doing right now. Well, let's say I open all of these up and I change this connection string to Cosmos. And I run it right now. So this is a simple Cosmos DB. It's set at 400 RUs right now.
Yeah.
So it's doing the first one not that fast. The second one did it in 600 milliseconds.
It's way faster.
And that's the actual query. And it's now doing like 6,000 milliseconds. I'll wait for the next one.
Yeah, so the other one started around 7.
Yeah. 9, like. But this is the 400 limit. So it's also like pinching it, not allowing me to push a lot more in. It's actually growing at the moment. But especially the query, not on a partition
a lot
key.
faster.
So you can really see that you just push some data in, and Cosmos DB is just indexing everything for you. So this is the auto index function working for you.
So it's enabling you to have much faster queries if you not only want to look for a partition key, row key.
Yeah, indeed. So going to this one, let's play around with the scale actually. Because we said we had 400 capacity there.
Yeah.
And what was it? The ingress of the data was going with, what was it, like 8 seconds per 500?
Yeah, it
something?
started out with the Cosmos DB one, right?
Yeah, with the
Yeah,
Cosmos
it started
DB.
out with 6.6 and then it went up into 8 and then even we touched on 9.
So I went from 400
Just
second
10,000.
to 10,000. If I would put more in it here, it will give me warnings like, we want to wait for that because we didn't reserve that capacity. So it takes a few seconds. Yeah, I tried it. Just smiling.
Yeah.
This is like
I know.
$20 daily basis. Also, yeah, not that terrible, but it's a different scale, and it already did that. You just pressed save.
But it's more. It costs you more than when you have a storage account where you just have table storage and you push stuff in.
That costs peanuts, of course.
Yeah.
But let's see if you really need this skill. So I have all the 3 methods there. I don't think because it's only one hit, the querying and the retrieving will be any faster. But putting the data in is actually, yeah, it's a bit more. So hitting the 10,000 is easy.
Okay.
So that's
Okay.
ingress
So
of
that's
10,000.
pretty impressive.
That is pretty impressive because what we saw on table storage was also maximum. If you have some process where you need to do the initial import, for instance, just put this thing to 50,000 or whatever, scale it up, push it there, scale it back down, and then start using your application.
So the scale and the number of resource units that you reserve, does that also have an impact on how fast your data will be indexed? Or it's just indexed in the back and nobody knows where the resources are getting from?
I didn't see any detailed explanation about what the resources were used for, but it can become quite complicated once you look at it.
I understand.
Also, with the 400 RUs, it's not just hits on the API, but write hits are more expensive. So it is a background thing. You can read up into it if you want. There's some blog posts about it. Maybe I can find it to share it.
Yeah.
But yeah, it's a bit hard to grasp. But if you need it for an instant, or you see how fast it scales because all the infrastructure is ready for you there to use.
It's pretty impressive.
And if you, for instance, say this, it will give you, I told you about that, it's like, look at the amount, what it will get.
Yeah.
It will work, but it will take some time, and then it will actually scale up for you.
And it's only $768 a day. So.
Yeah, that's nothing, right? So they say it's unlimited.
Wow.
The only thing, I don't know, I think maybe 64-bit int might be the limit for this input field, but
I'm going to try on a sponsored subscription.
yeah, that's my MSDN subscription won't hold that.
No.
No, but to show you that if you went for table storage, you had a good designing there, you had some edge cases with looking up query, or your scale actually grow beyond that. Might be interesting to look at this one, because if you have it at 400 or 500 RUs, for most of the cases I tested it, it felt a bit comparable. So if you go for like an account of $2 a day, that's more expensive than table storage, but still not a big problem for most successful
and then
projects.
And then performance, well, it just increases exponentially.
And in some cases, don't know for this one, we'll see, but I also saw the auto tuning or the auto scaling on there, where you only have to give a limit, a maximum limit. So it's interesting, but this is like giving your credit card away.
Here, have fun.
I don't know.
Yeah, let's not do that one for now.
Yeah.
Thanks for the cool demo, and we'll see you soon.
We'll see you next time.
Bye.
Bye.